Problem number 37, which is four graphs that you have to, four functions you have to graph, A, B, C, D. I suggest you pause the video and take the notes that are in front of you. All right, this is everything you need for the graphing rational functions for Algebra 2 1 level. So take a second, pause it, come back. All right, take those notes. See you in a few minutes. All right, 37a, y is equal to 2 over x minus 4. All right, we're looking at the version where x, without x in the numerator. All right, in this case, our ha is going to be y is equal to 0. Since this is 0, there's no k value over there. Our va, setting our denominator equal to 0, we get x is equal to 4. All right, our y-intercept, because we have a horizontal asymptote of 0, we don't have a x-intercept. All right, our y-intercept, all right, if we set our x value to 0 and solve, all right, we can see if we set this x equal to 0, we end up with a negative 1/2. So 0, negative 1/2. All right, our domain comes from our va. All right, and so since our va is x is equal to 4, our domain is all real numbers x not equal to 4. All right, our range is all real numbers y is not equal to 0. All right, and we have everything there. All right, getting a table of values, we want to make sure that we put this in a calculator correctly. All right, we want to go 2 divided by, and we have to put our denominator in parentheses since there's more than one term there. All right, anytime there's more than one term in the numerator or denominator, you need to put it in parentheses. All right, we get a table of values. All right, we want values above, we want to split our table of values at the error. All right, so our error is our va. All right, we can see that from the graph. All right, from the table of values. So we have 1 that we're going to go 3, 2, 1, let's say 0, 3, 2, 1, 0. All right, and the 3 was 3, negative 2, 2, negative 1, 1.667, which is 2/3. 2/3. 0, negative 1/2, which we already knew from our y-intercept. All right, and then the other table of values after the error is 5, 2, 6, 1, 7, 2/3, or 0.6 repeating. All right, 8 is 1/2. All right, or 0.5, and that should be enough to graph this. All right, so let's take those values. All right, put them on our table. All right, so first thing, horizontal asymptote. All right, we go y, in my class we go y is equal to 0 on one side, and we write ha on the other. All right, vertical asymptote. Is that x is equal to 4, 1, 2, 3, 4 here. All right, one end write va. All right, other end write the equation. All right, you will have to graph something like this. All right, and then let's get those points. Let's go 0, negative 1/2. All right, 1, negative 2/3, a little bit lower. 2, 1, negative 1, sorry, and 3, negative 2. So we can see what our shape. All right, remember we're not trying to intersect those asymptotes. All right, so our graph will go. All right, arrows at the end of our graphs. All right, second one. Guess I'll just do this color. 5, 2, 1, 2, 3, 4, 4, 5, 2, 6, 1, 7, 2/3, 8, 1/2, and so forth. And we see that our graph is like that. And we're done with that one. Everything's there. All right, B, y is equal to x plus 4 over x minus 3. This is the version where there is an x in the numerator. All right, first things first, let's put some coefficients here, 1 and 1, because that's going to help us get our horizontal asymptote. Our horizontal asymptote are our leading coefficients, which is 1 over 1, which is 1. All right, y is equal to 1. All right, vertical asymptote, set your denominator equal to 0. X is equal to 3. X-intercept, well, in this case, our x-intercept, we want to look at our, we can look at our numerator. All right, we can set our numerator equal to 0. All right, it's going to give us a negative 4, 0. All right, our y-intercept, and, oh, wow, yes. Our y-intercept in this case, we want to set x equal to 0, all right, and we get a negative 4/3. All right, if we just cover that up, we can see that we get 4 over negative 3. All right, so a negative 4/3. All right, our domain. All right, our domain goes with our va. All right, remember it goes with our va, and so we got all real number. X is not equal to 3. All right, and our range and our ha go together, horizontal asymptote. So our range is all real numbers. Y is not equal to 1. All right, so we can sketch that, and we can also start to work on getting our equation in. Remember, if there's more than one term in a numerator or denominator, you definitely need to use parentheses. All right, so we're going x plus 4, all right, divided by parentheses x minus 3. Please remember the parentheses, or you're going to get a improper equation function in the calculator. Do it wrong. Don't want to do it wrong. All right. All right. So I know where my va is. So I should have an error. I should have an error at x is equal to 3. All right, which I have. All right. Remember, I want to take numbers above the error. All right. So we're going to go 2, negative 6. 1, negative 2.5, all right, 0, and that is negative 1 and 1/3, which is 4/3, and that's what we have above. 0.3 repeating, 1 1/3. All right, or negative 1 1/3, negative 1 and negative 0.75, or that's 75 is 3/4. All right, so you got one table. Then you want a table to the right of the error or below the error. All right, that's 4, 8, 5, 4.5, 6, 3 1/3. All right, we can go to 7, 2.75, or 2 3/4. All right, got enough values. Let's get an asymptote. All right, asymptote is that y is equal to 1. All right, remember we want to go, we want to label ha on one side and y is equal to 1 on the other. All right, our va is at 3. All right, vertical asymptote, you can put va up there or below, and on the other side, right, x is equal to 3. All right, got that going for us. That'll definitely help us with this graph. All right, putting points in, 2, negative 6, 1, 2, 3, 4, 5, 6. All right, 1, negative 2.5. All right, and the graph starts to take shape. Negative 1/3, 0, negative 1/3, and negative 1, negative 3/4. All right, so we can see that our graph will go up, and it will go across. I think that was negative 4, 0. All right, and get closer and closer, never intersecting that. All right, 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. 5. 4.5, 1, 2, 3, 4.5. Next value, and 1, 2, 3 and a third. All right, 7. And let's go to 10 2. All right, yeah. And our graph goes like that. And we're done. Everything's there. All right, C, y is equal to 2 over x plus 1 plus 4. All right, in this case, our ha, so y is equal to 4. Our va, same thing. We're going to take our denominator, set it equal to 0, and solve. X is equal to -1. All right, we're going to come back to x-intercepts and y-intercepts for a second. Our domain is all real number, x is not equal to -1, and all real numbers, y is not equal to 4. All right, getting a table of values. Since our va is -1, I already know I'm going to go -2, -3, maybe -4 and find another value. And I'm going to go 0, 1, 2 and maybe find another value. All right, we put the equation in. All right, and it's 2 divided by parentheses x plus 1, close it, plus 4. All right, and then that way we get our table of values. We should have an error at -1 if we're doing it correctly, and we do. All right, sorry. All right, we got -2, 2, 3, 3 and 1/3, -5 and 3.5. All right, and then 0, 6, 1, 5, 2 is 4.6 repeating. All right, 3 is 4.5. All right, so we have everything. Oh, I'm sorry. Going back to find our y-intercept, we want to make this 0, right? All right, we'll make x equals 0. That gives us 2 plus 1, which is 2 over 1, which is 2, plus 4, which is 6. All right, and that was right there in the first place. All right, so let's see what we can do here. All right, our asymptote first. All right, x equals -1. All right, there's a reason why I made this graph a little different than the other two. This x is equal to -1, and that's my va. All right, my ha is 4. And that's y is equal to 4. All right, and then we want to plot these points. -2, +2, -3, 3, -4, 3 and a quarter, a third, and then there. All right, so we can kind of see what's going on here. Sorry if my hand is in the way. All right. Next one. Next branch. All right. 0, 1, 2, 3, 4, 5, 6. All right. 1, 5. And then we get closer and closer to that asymptote. All right, we can see that our graph is there. All right, so our yes. All right. There. All right, and finally, problem D. All right, our ha. All right, we want to first put a 1 there in front, and we can see that our ha is y is equal to 4. Our va, we want to set that equal to 0 and solve, so it's x is equal to -3. All right, our x-intercept, we want to set our numerator in this case equal to 0. That's going to give us 4x plus 2 is equal to 0. 4x is equal to 2. All right, and x is equal to 1/2. All right, so that's going to give us 1/2 comma 0. Our y-intercept, we want to make all our x's equal to 0, and we see that it's going to be 0, and then we have -2/3, which is -2/3. Our domain, all real numbers, x is not equal to -3. Our range from our ha is all real numbers, y is not equal to 4. All right, getting our table of values. Parentheses, if you don't put in parentheses, you're probably going to get it wrong. -2 divided by parentheses, x plus 3. All right, get a table of values. Now our error should be at a -3, and we do have an error there, so great. All right, so getting our two table of values split by our vertical asymptote. -4, 18, don't know if it's going to fit on the page. -5, 11. -6, 8 2/3, because it's 6 repeating. -7, 7.5. -8, 6.8. All right, plenty of values there. All right, actually we'll erase this last one and put this whole number value. I'm not sure if it fits, but -10, 6, I think it does. All right, going on the other side of the error, we have -2, -10, -1, -3. I'm going to skip one. Well, I don't want to skip a 0 value. All right, 0 and -2/3. 1, 1/2, 4, 2. All right, we can go to 11, 3, but I think that might be too much. All right, so let's plot those points. All right, -10, 6. Oh, before I plot points, I'm sorry. We need to put our va and ha in here. Vertical asymptote is at -3. Va, x is equal to -3. Our ha is at 4. 1, 2, 3, 4. My students go, well, do I have to write the ha on one side? Yes, you need to do all of that. Do all of that. All right. Okay, so let's go back to plotting points. I think I just erased a point. Great. 1, 2, 3, 4, 5, 6. All right. -7, 7.5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7.5. All right, I'm going to skip over to -5, 11. 1, 2, 3, 4, 5, 6. Oops. 1, 2, 3, 4, 5. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. I should have known. All right, and then 18. So this is 10. This would be 20, so that would be 18. All right, if I have all that there. All right, graphing. Ooh, it's kind of rough there. Alright, shouldn't bend back. Should bend closer to your asymptote. Alright, -2, -2, -10, -1, -3, 0 and -2/3, 1 and 1/2, 1 comma 1/2, 1, 2, 3, 4, 2. All right, and 11, 3. All right, so it's nice to have a big graph, but I have it. I don't know if you do, but there are your points. All right, and there's your graph. And there's problem number 37. Thank you. Problem number 38. First thing we want to do is start by factoring. So first numerator is x minus 2, x plus 2. All right, in first period we called this the Cedric factoring, right? Difference of two squares. Same thing for up here. This is x plus 5, x minus 5. All right, by first denominator. All right, we're looking for two numbers to give us a product of -10 and a sum of -3. All right, those two numbers are what? X minus 5, x plus 2. All right, and we have a x minus 2. So in this problem, and I think this exact same problem is in your unit test review. You can go back and look in there. That happens over and over. All right, we can, anything in the numerator we can cancel with anything in either denominator. All right, so we cancel our x minus 5s, we can cancel our x minus 2s, and we can cancel a pair of x plus 2s, and that leaves us with a x plus 5 as a final answer. 38b is a division problem. All right, and for division fraction, what do we say? Keep, change. All right, keep, change is what some people say. So at the same time, we're going to factor this. So we have the 6. We're going to factor this denominator. We get x minus 5, x plus 3. The division changes to what? Multiplication. All right, and we flip this. All right, and that's x minus 5 over 12. So we kept, we changed. All right, now from here, all right, if there's something we can cancel, let's cancel it. All right, x minus 5's cancel. You have 6 over 12, and 6 over 12 becomes 1 over 2. All right, and so that means what we have remaining is in our numerator we have 1 times, 1, which is 1. In the denominator we have 2 times x plus 3, and that's an acceptable answer. Alright, other problems we do in number 39, problem letter A and problem letter C are the most common problems we see on the final from at least this problem. We don't have like denominators at all, so we're going to multiply the second one by x plus 5 over x plus 5, and multiply the first one by x plus 4 over x plus 4. Alright, now from there we're doing distributive property here. Alright, and we're doing distributive property here. Alright, that will give us a x squared plus 4x, alright, over x plus 4, x plus 5, alright, and a 5x plus 25 over x plus 4, x plus 5. Alright, from here we want to add our numerators now that we have like denominators. We end up with x squared plus 9x plus 25 all over x plus 4, x plus 5. We want to check to see if we can factor this. We're looking for a product of 25 and a sum of 9, and I'm pretty sure that's impossible. Alright, to factor. All right, and so we are done. All right, 39b. Once again, we don't have like denominators in the least bit. All right, so we want to multiply the first the first fraction by x minus 3 over x minus 3. And multiply the second fraction by 2x plus 1 over 2x plus 1. Alright, doing distributive property. Alright, we'll give you a 4x squared minus 12x all over x minus 3, 2x plus 1. Alright, and now we put the minus sign here. Now when we do the second fraction, our numerator needs to stay in a parentheses. Alright, so we go 2x times 2x is 4x squared. Alright, plus 2x. Alright, we keep that in parentheses. We'll make sure that we get the right answer in the end. X minus 3, 2x plus 1. Alright, and now we can subtract these two. Okay, I'm going 4x squared minus a 4x squared. Alright, so they actually cancel each other. Alright, and we're going negative 12x minus a 2x, which is going to give us negative 14x over x minus 3, 2x plus 1. Alright, and we're done. Put this around there. Alright, 39c. Alright, this is a problem where we start looking at LCDs. Alright, first things first, if it's 4 over 1, put 4 over 1 and 5 over 1. Now, we're looking at all four of these denominators to figure out what our LCD is. Alright, and there aren't any common values here, so our LCD will just be, we would just multiply our different denominators. Alright, and so our LCD is going to be 3x. Now, this is the problem. If you remember in my class, we did a bunch of circling. Alright, we multiply each piece by the LCD. So we go times 3x over 1 times 3x over 1 times 3x over 1. Hopefully some people are going, oh yeah, I remember this. Alright, so from there, we can circle each piece because we pretty much have 4 separate problems. Alright, circle, 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 circle. Alright, and we just want to cancel what we can cancel. Alright, here we can cancel the 3's. Here, nothing to cancel. Here, nothing to cancel. And here we can cancel the x's. Alright, so let's see what we have left over. Here we have an x times x, which is x squared. Here we have, got a minus sign, and we have 12x. Alright, here we have 15x. And here we have 3. Alright, and so there is your 39C. That's it. Alright, problems like number 40. We had some rules. We said first we were going to find the LCD. Then we're going to multiply each term by the LCD. This eliminated our fraction, and then we solve. Now, those are the rules for any problem, any of these rational equations that we were doing. Now, if it's a problem where you have a fraction equal to a fraction, you can always cross multiply. But since those are not the rules that we used in class, because we wanted rules that fit every problem, I'm not going to do that. If you do that, that's fine. You're just going to skip to the third step. All right, but we're going to look at this. We have an x and a 5, and so our LCD is going to be 5x. We're going to multiply each term by 5x over 1 and 5x over 1. All right. In turn, this allows us to cancel our x's and then cancel our 5's over here. All right. We will still end up with a 5 times 11 is equal to x times x plus 6. All right, because that's what you have left over. All right, we've eliminated our fraction. And then from here, we're just solving. All right, 55 is equal to x squared plus 6x. It's an x squared. And remember, when you have an x squared at this step, we want to move everything to one side. So we don't want to split our x's up in our constant sign. All right, so we're going to move this 55 over. All right, by subtracting 55 or just moving across the equal sign. When you move it across the equal sign, it changes signs. All right, so we have 0 is equal to x squared plus 6x minus 55. Now, let's see if we can factor that. We're looking for two numbers to give us a product of negative 55 and a sum of 6. 1 and 55 is definitely not going to work. 5 times 11 works. All right, but we have a negative with our 5. All right, so that gives us 0 is equal to x plus 11, x minus 5. All right, we want to do zero product rule to finish this out, which says that x plus 11 is equal to 0, or x minus 5 is equal to 0. I know a lot of people do zero product rule, all that. I just want to get to x is equal to negative 11 and x is equal to 5. But this is the proper way. All right, and that's what we get to. X is, we subtract the 11 from both sides. We get x is equal to negative 11, and we get x, and we add 5 to both sides. We get x is equal to 5. All right, now, at this point, we would just want to, if we check our answers, all right, and we do want to go back and check our answers for the sake of time. I'm not going to check these answers. You're going to go back and check these answers. And I'm just going to let you know that both answers work. All right, more than anything, we want to check and make sure we don't end up with a zero denominator, all right, after plugging in. All right, that's that quick check, all right. But both of our answers are correct for this problem. All right, 40b, once again, it's a fraction equal to a fraction. You could just go right into the cross multiplication step. We're going to use the rules for each and every type of problem like this. And next year in pre-calc, if you happen to take pre-calc, you really get into a lot of these where it's more than just a fraction equal to a fraction. All right, in this case, our denominators are not like at all. There are no common factors. And so we're going to multiply this one by x minus 1 times 2x plus 7, all right, because that's our LCD, and multiply this one by the same. I'm going to erase this 40b, put it down here, all right. That's x minus 1 again times 2x plus 7. All right, like I said, these steps work for everything. You can just cross multiply if you want. All right, here, and here. All right, that leaves us with a this x times x minus 1 is equal to x minus 5 times 2x plus 7. All right, looks like we got a little bit of work to do. We got to do that four-letter F word that begins with F and ends in foil. All right, and if we do that for this, do a couple extra steps here. First, all right, we're going first, outer, inner, last. All right, that's 2x squared plus 7x minus 10x minus 35. All right, here we have x squared. We're doing distributive property. X squared minus x. All right, combining like terms, we end up with x squared minus x is equal to 2x squared minus 3x minus 35. All right, we want to bring everything over to one side anytime we have an x squared in the problem at this point. All right, so we're going to subtract x squared from both sides. We're going to add x to both sides. All right, and doing that and one step that cancels that, I have 0 on that side. All right, 2x squared minus x squared gives us an x squared minus 2x minus 35. So we're looking good. All right, we're looking for two numbers to give us a product of negative 35 and a sum of negative 2. What is it? Negative 7 times 5, negative 7 plus 5. All right, so our numbers here, x minus 7, x plus 5. All right, excuse me. All right, zero product rule yields x minus 7 is equal to 0, or x plus 5 is equal to 0. All right, now lets us know that x is equal to 7 or x is equal to negative 5. All right, problem number 41 is another matching problem. And we're going to do this just by vertical asymptotes and horizontal asymptotes alone. All right, if we know our V's and Ha's, we can knock this problem out. All right, so let's see if we can do that. All right, looking back at your rules, in this case our VA is x is equal to 3. The VA here is x is equal to 3. The VA here is x is equal to negative 2. And the VA here is x is equal to 2. Our horizontal asymptote for this one is y is equal to 0. Our horizontal asymptote here is y is equal to 1. Our horizontal asymptote here is y is equal to 1 over 1, which is 1. And here our horizontal asymptote is 3 over 1, which is y is equal to 3. Now, that alone should give you enough information for 41 that A is 3, B is 1, C is 4, and D is 2. Thanks.